Okay, we are back. We are now going to I'm going to go over the homework on antidifferentiation by method of substitution, which is just to do pages 2, 4, and 6 of the packet by yourself. Page 2 is, I think, quite easy. Page 4 is maybe harder, is actually pretty hard, and page 6 is by far the hardest. So good, woo, let's go. Hopefully you're getting better at this, and you already watched the whole other video, and finished pages 1 through 5. So I don't have much to say about these problems on page 2. But anyway, here we go. I want the antiderivative of ln x to the 4th over x. And okay, well, being kind of experienced with this, I see that natural log is the inner function and 2 to the 4th is the outer function, and the derivative of natural log is 1 over x, and 1 over x is just sitting there. So that's all there is to it, right? I let u be ln x. du is therefore 1 over x. dx, already kind of skipping a little bit that step. And 1 over x dx is just exactly what I have. And so this problem becomes just u to the 4th du. And u to the 4th du is 1/5 u to the 5th plus c. And so this is 1/5 ln x to the 5th plus c. Yeah, that problem you might be tempted to just do the whole thing in your head. It's that easy. I can't stop you. Okay, number 10. Antiderivative x squared root 2x cubed minus 1 dx. Well, does it look like some chain rule happened here? Yes, it does. Because there is an inner function, 2x cubed minus 1, and its derivative is 6x squared, which is give or take what we have here. So this x squared is the back and side. Okay, so now I can just do it. Let u be 2x cubed minus 1. Du dx is therefore 6x squared, and so du is 6x squared dx. Cha-cha. Well, I need there to be a 6 in there, so I stick in the 6 and I undo the damage with a 1/6. And so then this whole thing becomes 1/6 antiderivative u to the 1/2 and 6x squared dx is my du. And I put it in antidifferentiation friendly form. Okay, what is the antiderivative of u to the 1/2? I go up a power to 3 halves and I divide by 3 halves. So it's 2/3 u to the 3 halves plus c. And that becomes 1/9, therefore 2x cubed minus 1 to the 3 halves plus c. Okay, I think I can squeeze one more in here. This is sine of ln x over x dx. Well, again, the inner function is clearly natural log, so I just want to let u be the inner function, and if I do that, I get that du dx is 1 over x, and therefore du is 1 over x dx. But 1 over x dx is exactly what I have sitting there already, so this immediately turns into sine u du. Boom. And I know that is the antiderivative of sine is negative cosine u plus c, and therefore this becomes negative cosine of the natural log of x plus c is my final answer there. Okay, more 12. Oh, okay, this one is mildly interesting, maybe you might say, or not actually. Root x plus 4. I take it back. This is pretty boring. Here you would probably not only. I mean, this is kind of lame to do the substitution explicitly. Almost no one does this, but I'll do it. Let u be x plus 4. So that du is then just dx in this case, and if du is just dx, then this whole thing can be written as root u du. Yeah. Okay, so that's u to the 1/2. What's the antiderivative of u to the 1/2? Up a power to 3/2, divide. So like I just did a minute ago, I think it's 2/3 u to the 3/2 plus c. And so this whole problem is then 2/3 x plus 4 to the 3/2 plus c. Okay. Good. 13 is another problem that if you are starting to feel very confident, you might want to try to do kind of in your head without doing the explicit u sub, but I don't really recommend it. Okay, here you let u be 6x because it's the inside function, and then du dx is 6, so du is 6 dx. And I don't have a 6 in there, I have a 4, so you know, whatever. You can, there's multiple ways to do this, but you could just stick in the 6 and undo the damage with a 1/6. And now pulling the 4 out, this gives me 2/3 cosine u du. Cool. So, okay, are we starting to get a sense now that the u substitution is really just, yeah, I've said this already, it's just it's a technical device which enables you to keep track of all of your various constants and things so that you're only ever doing sort of like one thing at a time. So this to me is just the cleaner way to do it, even though it's a little bit more writing. Now I can just say with confidence that this is antiderivative of cosine is sine, because the derivative of sine is cosine, so 2/3 sine u plus c, so it's 2/3 sine 6x plus c is the answer there. Okay, squeeze one more in. Number 14, I think, is just basically more of the same. So that's x squared sine of 14. Wrong problem. 14 is x over root 2x squared plus 1. Well, here there's a clear inner and outer function. The inner function is 2x squared plus 1. So if I let u be 2x squared plus 1, then du dx is 4x. Fact. So du is 4x dx. That's more or less what I have just sitting there, except for the 4. So I put in a 4, undo the damage with a 1/4, and thus this problem reduces to 1/4 antiderivative. I guess there was a dx just chilling out there that I neglected, but 4x dx is just now du over, and then this is just root u. Okay, but that's really 1/4 antiderivative u to the negative 1/2 du, I think is the more helpful way of putting it. So that's going to be 1/4 times, what's the antiderivative of u to the negative 1/2? You go up a power to 1/2 and you divide by that power. So when you divide by 1/2, it's like times 2 plus c. Final answer, 1/2 u root u, or in other words, root 2x squared plus 1 plus c. Looking good. Okay, 2 more on this page. Okay. Yeah. 15. 15. Antiderivative x squared times sine of 4x cubed plus 8 dx. Okay, again, pretty straightforward. I'm going to let u be the 4x cubed plus 8 because it's the inner function. Thus, du dx is 12x squared. So du is 12x squared dx, and I don't have 12x squared dx, I just have regular x squared dx. So I stick in a 12 and put a 1/12 on the outside to cancel that action. And so this whole problem becomes 1/12, 12x squared dx is du, and so we get sine u du. Now just, do you know the antiderivative of sine u? It is negative cosine u plus c, and so the answer to this problem is negative 1/12 cosine of 4x cubed plus 8 plus c. And at any point, you can double check your work by simply doing the chain rule. If you take the derivative of this function, you should get back the original thing. Okay, last one from this page. Just getting a little bit more complicated, but not actually harder. X squared over the cube root of 2x cubed plus 7 dx. All right. Well, once again, there's a clear inner function, which is this 2x cubed plus 7. So if I let u be 2x cubed plus 7, then du dx is 6x squared. Yeah. So du is 6x squared dx. And so I need there to be a 6, which there isn't. So, man, really getting in the zone now. Stick in 6, undo the damage with a 1/6, and then this becomes 1/6 antiderivative of du over the cube root of u. Okay, I think it's important to rewrite that in antidifferentiation friendly form. So that's 1/6. What is 1 over the cube root of u? Well, that's just u to the negative 1/3. And writing it that way makes it more clear what's going on. What's the antiderivative of u to the negative 1/3? Well, you go up a power to u to the 2/3, and you divide by 2/3. So this is 3/2 u to the 2/3 plus c. And thus we get really, what is that? 1/4 2x cubed plus 7 to the 2/3 plus c. Yep. Okay, good. That was page 2. And I hope, well, I think this is the appropriate amount of practice to get really, really good at this. I hope we are now seeing, at least in these straightforward cases, how to, well, not just how to do the problem once you figure out what u is, but also how to recognize u clearly. Okay, so then things do get more challenging, and page 3 is already getting a little challenging. So these are kind of like little puzzles, you might say. No, sorry. 3 we did already. I mean to go to page 4. Yeah. Okay. Page 4. 23. Alright. 1 plus e to the t squared over e to the t. Alright, well, the derivative of e is e to the t is e to the t. So you might think that some kind of substitution were possible here. And I guess there is. I could, well, no, I guess there just sort of isn't, actually. Because, yeah, if you try things, they just won't work, right? If you, maybe this is a good opportunity to talk about trying and failing. If you suppose you just kind of not thinking about it too much, let u be e to the t. Well, okay. Then du would be e to the t dt. But now when I go to do the substitution, I guess I get like 1 plus u squared over, I don't know what to do. I suppose that has to be a u. But then I need there to be like a du there, and there just sort of isn't. So it just kind of doesn't work. It just doesn't work. Okay, Well, if that doesn't work, perhaps I should try to let u be 1 plus e to the t. Well, now du is going to be, again, e to the t dt, so that seems better, because now I have something simpler up top, u squared over, and I guess that would be like u minus 1 or something. But then once again, I don't have the method of substitution also sort of forces you, so to speak, by following the algebra to solve for du in terms of dt, but like I just don't have that or something. Yeah. So that doesn't work either. So well, what can we do here? We got to think a little bit, and well, once again, you should maybe see that since this denominator is a single term, we would like to split up this fraction into as many pieces as possible. And so the way to do this problem, one sees after thinking about it a little bit, is to just multiply out the top. And you get e to the t times e to the t, which is e to the 2t, plus 2e to the t, plus 1, over e to the t. And here, because e to the t is a single term, I can just easily just perform this division, and then that gives me e to the t plus 2 plus e to the negative t. And so actually now, well, okay, depending on how, yeah. Okay, so this would be, of course, the antiderivative of e to the t is just e to the t. The antiderivative of 2 is just 2t. And now I just have this to do. Okay, almost everyone would just do this in their head, but really what you can do, or maybe should do if you're a beginner, is to do the explicit substitution where you let u be negative t, and then du dt is negative 1, and so du is negative dt. In other words, there's this negative in here, so then we have to put a negative 1 on the outside. Which is why this becomes a negative antiderivative e to the u du, and then so that's why this is just negative e to the u. So it's negative e to negative t. Okay, so that is the final answer there. Yeah, because of the chain rule, the derivative of e to the negative t is e to the negative t back inside negative 1. So that's why that gets you back here. Okay, that's fun. Let's do 24. This is another problem in which some algebraic creativity is required. So e to the negative x plus 1. Okay, what am I going to do now? Well, once again, I'm at a loss. If I try to let u be e to the negative x, say, which is maybe a reasonable idea, it just doesn't work because du is negative e to the negative x. And I just don't have one of those there to complete that substitution. So I have to try something else. And one thing to try is to just algebraically manipulate the thing I'm trying to differentiate first to see if it can be put into a simpler form. And here, just recall that e to the negative x really just means 1 over e to the x. So this whole thing becomes 2 over 1 over e to the x plus 1. All right, and that might be considered more complicated, but of course I can continue with this manipulation by getting a common denominator in the denominator. So that's 2 dx over, well now that's, right, this is just like 1 plus e to the x over e to the x. In other words, by fraction rules, this becomes 2, and then e to the x dx over 1 plus e to the x. And while that might seem more complicated, now I think the substitution is coming into focus because the derivative of 1 plus e to the x is e to the x. And in fact, therefore, we let u be 1 plus e to the x. Du dx is e to the x, because derivative 1 is 0. So du is e to the x dx, and then I can rewrite that in terms of u's. So that becomes 2 du on the top, and on the bottom u. This is a natural log problem. So answer 2 ln absolute value u plus c. And so the final answer is 2 natural log. I think I can just drop the absolute value because if you want to, because 1 plus e to the x is always positive. And so there is the answer to that problem. Okay, 2 more on page 4. Yeah. 2 more on page 4. 25. Okay, this is kind of tricky, and alright, there are ways to do this that are not the way I'm about to show you, but they involve you already knowing things, and I'm teaching this in kind of a weird way, so that you don't know a lot of basic things. Because I want you to just get really good at just doing things using, your wits or whatever. Okay, so if all we have are our wits, man, oh man, am I about to get stuck. I have no idea what to do. If I try things, they all don't work. Perhaps we let u be 1 plus sine x. Well then du is cosine x dx, so that appears promising until you recognize that the cosine is like in the denominator and like it shouldn't be there. And so if you pursue this substitution, it just doesn't work. You just get a du in the bottom, which is just meaningless. So that's sad. What if you try it the other way, where you let u be cosine x? Maybe that's more promising, actually. Then the derivative of cosine is negative sine. So, alright, so things are looking good for a minute, but then, what is it that I have here then? On the top I have something like 1 minus du or something. That doesn't even work. It just, once again, it just doesn't work. If you try to do this, you just get stuck and you just get garbage. So, yeah, it's a good time to just get totally stuck. What can we do? Oh man. Well, probably what a professional would do, or if you asked someone who already knows calculus, I know what they would tell you to do. They would tell you to split this up into 1 over cosine plus sine over cosine, and you get secant x plus tan x. Okay, but that assumes that you know how to antidifferentiate tan. We don't know how yet, if you're only learning from me. And how to differentiate secant. We also don't know how to do that. So that's not really helpful as a strategy, although we're going to learn that next week. Alright, so what can we do? What's going on here? Well, there's another relationship between sine and cosine. There's the Pythagorean relationship. And so you have to take the initiative here to multiply by the conjugate. And if you multiply by the conjugate already, maybe some people are seeing that this is just a brilliant idea. Because now, I guess I'm going horizontal for this problem. Now I have, well, what do I have? On the top I have 1 minus sine squared, and on the bottom I have cosine times 1 minus sine x. Okay, that seems maybe a lot worse, but of course 1 minus sine squared x is just cosine, so I don't know why I'm showing so many details. Cosine x 1 minus sine x. This is giving me the illusion of having a large board, so that's really making me happy. So the cosines cancel, and now I am here. I have cosine x in the numerator and 1 minus sine x in the denominator. And okay, that might appear that we've gone in a big circle because these two don't appear to be any different from each other at all. In fact, they're equally bad or equally good or something, but actually now things will work out. Because now, if I let u be 1 minus sine x, then du dx is, well, the derivative of sine is cosine, so that becomes negative cosine cha. And that means that du is, well, negative cosine x, sorry, should have said that. Du is just negative cosine x dx. And now, I can stick in a negative, undo the damage, and this is just how you do this problem. And this gives me negative, the top negative cosine x dx is just du, and the bottom is u. And that problem I know to be negative ln absolute value of u plus c. And so this problem becomes negative ln absolute value 1. Have I done something wrong? No. 1 minus sine x plus c. Okay, I remember now. So this is, it's perfectly correct to leave your final answer like this, but note that many people, including textbooks and people like that, will almost never, just kind of by tradition or something, leave a negative out there in front of the natural log, because they will apply a log rule. And thinking of that negative as like a negative 1, that means that this is ln of 1 minus sine x, sort of like to the negative 1, right, by log rule. So that means that this is ln of 1 over 1 minus sine x. And, okay, you could probably just leave it like that. In fact, you would just totally leave it like that, I suppose. Let me stop talking. Okay, this is perfectly fine. This is fine. Other things are possible. You could multiply by the conjugate again, but I don't see why you would want to do that, so I'm gonna stop. Okay, last one from page 4 is this one. This is kind of a legit new thing now. So if you've never done this before and you didn't get any help from people and you didn't use the internet, I would be very impressed if you spontaneously figured out what to do here for number 26. Oh, I take it back. False alarm. 26 is easy. Oh, oops. What is 26? Negative 2x over root x squared minus 4. Okay, this is just same old, same old. Sorry. Yeah, I just let u be x squared minus 4. Du dx is 2x. So du is 2x dx. And that's pretty much what I have here, except there's this negative here. So what do? I take out the negative. This is kind of a silly problem. And I get du over root u. And that is negative u to the negative 1/2. And that is negative, the antiderivative of u to the negative 1/2 is upper power to 1/2 divided by 1/2, so it's 2 u to the 1/2 plus c. So this whole problem becomes negative 2 root x squared minus 4 plus c. Okay, good. All right, that completes page 4. It is on page 6 that things start getting really hard. So that's the page which I would be very impressed if you could sort of do on your own, because I didn't teach you how to do this yet, if you're following along chronologically. So anyway, here we go. 31 might be chill. It is. No, it's actually not. Well, okay, here we go. 31. Oh, I see. Okay, antiderivative, tan, this is perfect, 2 over t over t squared dt. Okay, this is an excellent problem. I'm glad we're doing this right now. Whew. Well, what do you notice? I see tan, and I see this 2 over t situation, which appears to be an inside function, and an inner function. And the derivative of 2 over t, if you're getting really good, is going to be some kind of like 1 over t squared, which is what's sitting here. Okay, so experience should tell you that if you let u be 2 over t, or perhaps you want to write it as 2t to the negative 1, then du dt is, well, it's negative 2t to the negative 2. And that means that du is negative 2 over t squared dt. And if that's what you have done off to the side, then it becomes clear that a substitution is the back and side, so to speak, the negative 2 over t squared is just sitting right there. And so everything's almost perfect. I need there to be another negative 2 up there. So I stick in a negative 2, I undo the damage with a negative 1/2, and I get negative 1/2 times the antiderivative of, tan t over 2 just becomes tan u, and negative 2 over t squared dt just becomes du. Okay, so this whole problem now rests upon my ability to antidifferentiate tan. Alright, this is an important thing that comes up all the time, so we need to know how to do this, and we don't know how to do this yet. At least I haven't taught you how to do this, so we're going to learn right now. How do we antidifferentiate tan? Well, it would be nice if the rule just kind of dropped into thin air, which is to say, do you know some function whose derivative is tan? And the answer is no. Derivative of tan is secant squared, derivative of sine is cosine, derivative of cosine, negative sine, etc. There is no just simple function that I'm aware of whose derivative is tan. So that doesn't work. So we're going to have to do something more complicated. How are we going to do this? It doesn't appear clear at all how to do this. Well, does it look like some chain rule happened here? Frankly, no, it doesn't. So now I will move on and do kind of the only thing I can do, which is to rewrite tan, method of last resort, as sine over cosine. And now, if we're kind of experienced with this, I do see some opportunities for substitution, because now it does look like some chain rule happened here. In particular, sine is the derivative of cosine, cosine is the derivative of sine. Okay, this is actually a good, I think, a good time to do this, because now we're getting sort of good, right? And you should now know which one we should substitute for. And the answer is the denominator. So I want to let w be cosine u, and therefore dw du is, well, the derivative of cosine is negative sine u, and that way dw